Alright, so this video is to get us started on Lab 3, Ohm's Law for DC circuits. So in this class we're going to be working with a 1 kilo ohm resistor and maybe some other values also. But we're going to have a 1 kilo ohm resistor, and then we're going to connect it up to a voltage supply, and we're going to vary the voltage values. We're going to use a digital multimeter to measure the voltage, and then we're going to use a second or another DMM to measure the current. So actually I got this one's just DMM, this one I labeled DMM2, but we're going to be using two digital multimeters simultaneously. One is going to be set up to measure voltage, and the other is going to be set up to measure the current. Okay. And so through this 1K resistor. Now the first thing that we do, and you're going to need to do this for every lab, but the first thing that you have to do is measure your resistance. Alright, so we did this in lab 2, but let's just kind of review that. So if we look over here, I have two resistors. This resistor here is brown, black, red, and silver. So the brown tells you that it's 1, and the black is 0, and red is 2. So that's 1, 0 times 10 to the second power. So this is a 1 kilo ohm resistor with a silver band, which means plus or minus 10% tolerance, right? So this is a 1000 ohm resistor. Now here's another resistor. This resistor right here is also, you can see that, is also brown, black, and red, just like this one, only this one is much smaller, right? So we can tell obviously that this one over here is much smaller, and the reason for that is the power rating. The large one is rated for 2 watts. The small one is rated at only a quarter of a watt, so 250 milliwatts compared to 2 watts. All right, but they're both 1K ohm resistances. So to measure resistance, remember that you have your meter here. You have this top left spot for your meter lead, and it says V and then omega. That's to measure either voltage or resistance. Your black lead, your ground lead, is always going to go in the middle left. And so if I want to measure resistance, I'm going to press ohms, and it says overload. Now overload simply means that the circuit is open. All right, so the meter leads aren't touching anything. So overload really means infinite resistance, or so much resistance that virtually no current is flowing. On the other hand, if I take the two meter leads and I short them together, right, all I have is the resistance in the wire leads, and so you can see that the resistance is 0.041 ohms, so it's about 41 milliohms, right? And that's basically just the resistance in the wires. All right, so but if I take this now and I put them on my resistor, and it doesn't matter which one of those, it doesn't matter if I put the positive lead on this side or this side, it doesn't matter which side you connect that to. But we can read this, and we can see that that is reading 990 ohms, or 0.990 kiloohms. So this is about 10% less than a kiloohm, or excuse me, 1% less than a kiloohm here. And so, and then this one, so the little one here happens to be a little bit smaller than a kiloohm. And the large one here, if I put this one on, it's actually reading about 1.06 1.07 kiloohms. So the large one is actually a little bit larger than a kiloohm, but they're both right there. They're definitely within the tolerance of their tolerance bands on there. So we have these two resistors here. All right, so now I'm going to use this meter as our voltmeter. So we kind of got this one off to the side. So if we look at our circuit again, all right, this is our circuit. We're going to connect up here. We're going to connect up the positive of the power supply into the positive of our current meter. And then we're going to come out of the negative of the current meter into the top of our 1K resistor. Then we're going to come out of our 1K resistor and connect back to the negative. And then we're going to measure the voltage in parallel. All right? So that's the circuit that we're going to have. And all right, so we have to hook this up. Now, before we actually hook it up, though, we need to set the voltage on our power supply. So down here we have this power supply. Now, this power supply actually has 3 different DC power voltages on it. So you see there's a red-black, red-black, and red-black connection. So each one of those connections will give us a different voltage that we can adjust. The middle one is just a 5 volt reading for TTL type logic, but the one on the left can give us anywhere between about 0 to 30 volts, and the one on the right can give us anywhere between 0 to 30 volts. And so, and they can also give us way up to something like about 3 amps, which is a large current, well enough to blow the fuses on our meters if we're not careful. So the first thing we want to do is look at the current knob. So we have 2 knobs here. We have a voltage knob and a current knob. The current knob, turn that completely counterclockwise, so it's going to have a minimum current. That minimum current is going to be about 30 milliamps. So pretty small current, but way more than what we need for this lab. So always make sure when you start out that your current knobs are turned all the way down. Now you can, it doesn't matter which supply, you can choose the left supply or the right supply. It doesn't really matter. They're essentially equal, but make sure that you have the current knobs turned down so that if you make a mistake, you're not going to blow a fuse. All right, so once we do that, we're we've got our current knobs turned down, and then we can adjust the voltage. Now there is a voltage display here, all right, but that voltage display is just a display. It's not a calibrated high precision number. So what we want to do to measure voltage is we need to take our voltmeter, take our DMM, put it in voltmeter mode, make sure we're plugged into the V connection here, and we can just put that on here and measure the voltage before we try to connect the circuit. So if you look at the alligator clip, there's like a large, there's a skinnier one that fits kind of inside of the larger one. This skinny one we can just slip right inside of those connections there, and we can see that this says 5.0 volts, 5.0 volts, but this says 4.96 volts. So we need to make sure that we adjust the voltage supply so that we get 5.00 volts on our meter. The meter is a calibrated instrument. The display is not calibrated, and so you want to make sure that you use that. If you use too large of an error, or too large of, if you don't pay attention to what you're doing and get too large of an error when you calculate your percent differences in the lab, you will lose points. Okay, so 5%. If your answers, your calculated answers and your measured values are more than 5% off, then you're not being careful or you're making a mistake somewhere and you will lose points. So always make sure that you use the meter to set your voltage so it's very accurate. Once we do that, we can now take a pair of meter leads. So we'll take a pair of meter leads and use those for our power supply connection. All right, so now before I connect up my current meter, I just want to show you I've got my voltage positive lead of my voltmeter and my 5 volts here and my negative. Now, I've got my current knob all the way down. You notice here it says the display is telling me that I'm basically at 5 volts and I'm at a constant voltage. There's a little light here that says CV, constant voltage. And you can see that the voltage is not changing. If I short this out, you're going to see that voltage drop. So I've just shorted out my power supply. This is really not a good thing to do. However, since I've got my current knob turned all the way down, it's limiting how much current down to less than 30 milliamps. It's not going to do any damage. All right. If I had that knob turned up, I could actually do damage. Do that. I could blow a fuse in my meter. I could overheat a resistor. I'm not going to hurt the power supply because the power supply has built-in current limiting, and so it's, you know, I shouldn't really damage the power supply, but I could damage other equipment, and I could get a resistor very hot and burn my hand or something like that. So we need to be very careful there. Number one, make sure this current knob's all the way down and you'll be safe. You can't blow a fuse or anything else if that current knob is all the way down. All right, so now what we're going to do is we're going to take this resistor here then, and we're going to connect up our 5 volts. All right, but if we look at our circuit, let's go back and look at our circuit. They want us to measure the current. All right, so if we measure the current, we actually got to come out of our positive 5 volt supply into the positive of our current meter, and then out of the negative of the current meter into our resistor. So I didn't do that, so I need to go back and try this again. So I'm going to come out of my power supply with the positive, and I'm going to go into the positive of my current meter. Now remember, I'm measuring current now, so I'm going into the bottom left connection of the meter. Voltage is the top left connection, but current is the bottom left, and of course the ground or the black lead always goes in that middle position. So I'm coming out of the black middle position here, the black lead, into the top of the resistor, out of the bottom of the resistor, back into my power supply. All right? And so now you can see I've got 5.04 milliamps. That's the current. It's already reading the current because I didn't turn power off. Now I'm going to take my voltmeter and connect it back in the circuit so we can see the voltage. And so you can see the voltage, it looks like it slipped down on me just a hair of 4.99. That's actually would be acceptable for the lab, but I'll bump it right back up to 5.00. All right, so this is 5.00. Now remember that this is the quarter watt resistor, and we measured it, and it was like 990 ohms. So it was slightly under the 1,000 ohms. So my current is slightly above 1 milliamp. All right. If I take this 1K 2 watt resistor, which if you remember, it actually measured about 1.07, I think, 1.07 kilowatts. So it was actually slightly above a kilowatt. So if I switch over to that resistor, we're going to see the resistance is actually about 4.7, so it's actually a little bit below the 5 milliamps expected. All right, so again, when you do your calculations, you need to make sure you use your measured resistances, because otherwise your errors are going to be larger than they need to be.